Good morning, students. We are going to revise our second chapter of chemistry, that is the concept of acid base. That is the acid, base, and salt. The name of chapter is acids, bases, and salts. So, I am going to revise you. Firstly, you understand what is acid. In your older times, you have discussed about acids are the substances which are sour in taste, and base are the substances which are bitter in taste. So these things you remember, but now we are having some new concepts, in which the first concept is Arrhenius concept. The Arrhenius concept of acids is those substances which produces hydrogen ions, that is H positive ions, in presence of water are known as acids. So the simple definition is the substances which donates its H plus ions in water is known as acids. Example, HCl, it can donate H positive. HNO3, it can donate H positive. When in presence of water, this H positive combines with water to form hydronium ion, which is known as H3O positive, that is hydronium ion. H2SO4, again two molecules of H plus will donate, hence two water molecules are required. It is known as dibasic. HCl is monobasic, H2SO4 is dibasic because it donates two H plus ions. Next we come to the concept of bases. Base are the substances which produces hydroxyl ions, that is OH negative ions, in presence of water are known as base. Example, again that is the sodium hydroxide, NaOH, KOH, potassium hydroxide, NH4OH, that is ammonium hydroxide, AlOH thrice, that is aluminium hydroxide. Okay, so all these give OH negative ions in presence of water, so they are known as the base. Next we are coming to the concept of limitations. This concept limitation, the very important limitation is if any compound does not have H plus or OH negative ions. For example, I am taking example of SO2, that is sulfur dioxide. It does not have any hydrogen, it does not have any OH, so according to Arrhenius, it can't be acid or base, but actually it is acidic in nature. So this is the limitation. It is not applied in non-aqueous solutions. If water is not present, then Arrhenius concept is violated, is not used, can't be used. So next concept is the concept of acid and base, that is the Bronsted-Lowry concept. So according to Bronsted-Lowry, acids are the species which are capable of donating a proton, which are capable to donate a H plus. If it is H plus, then it is the Arrhenius. But if it comes with a proton, then it is known as the Bronsted-Lowry concept of acid and base. After that, if any substance is accepting the proton, then the species is known as base. So base are the species which are capable of accepting a proton. So remember, acid proton donor and base proton acceptor. Okay, so remember this about the Bronsted-Lowry concept. Same limitations of this concept is also there, because any substance which don't have any proton or which are not capable to donate proton, so how we can identify about the acid and basic nature. Next we are coming to the properties of acids. Now the concept becomes very easy. Acids are the sour in taste, they are good conductor of electricity. Acids are highly corrosive in nature. The dissolution of acid in water is highly exothermic. Acids converts blue litmus to red. There are many more points. Acid reacts with metals to obtain salt and hydrogen gas. Acid reacts with metal oxide to give salt and water. So there are some concepts of properties of acids. Some properties of base are there. Base are bitter in taste. Rest some are same, that is good conductor of electricity. They are corrosive in nature and soapy in touch. Base converts red litmus to blue. This is the reverse of acid concept. Here same, base reacts with metal to form salt and hydrogen gas. Base reacts with non-metal oxides. In acids it is metal oxide, in base it is non-metal oxide to give salt and water. Next heading is what about the indicators. Those chemical substances which give different colors in different mediums, that in acidic or basic medium. So indicators are the substances which give different colors in different mediums to indicate the presence of that medium. Okay, so it is of three types. First is the natural indicator, second is the synthetic indicators, and third one is the olfactory indicators. So natural indicators are obtained from plants and detects the presence of acid or base. They are obtained from plants and detects the presence of acid and base. Example is litmus. Litmus is obtained from plant lichen having purple solution, and if we are going to extract, then it converts into two types, that is blue litmus and red litmus. Acidic solution changes blue litmus to red, but no change in red litmus. Basic solution changes red litmus to blue, but no effect on blue litmus. Okay, so this is all about the indicators. Next we are coming to the turmeric. Natural indicator turmeric we are using, that is the haldi, having yellow colored, remains yellow in acidic solution but basic in but red colored in basic solution. Next is the synthetic indicators which are prepared in laboratory. Examples methyl orange and phenolphthalein. Methyl orange is having orange color in neutral medium, red colored in acidic medium, and yellow colored in basic medium. Phenolphthalein, very important indicator we are using. Phenolphthalein is a colorless solution, remains colorless in acidic solution but pink colored in the basic solution. Next is the olfactory indicators, those chemicals which are used having different odors in different mediums. Example, onion has smell in acidic medium but no smell in basic medium. So if you want to get rid of the smell of onion from your mouth, use a basic solution or gargle with baking powder, baking soda. Next is the universal indicator and classifications. Acids are of two types, strong acids which are completely ionized and give large number of H plus ions. Example, HCl, H2SO4, HNO3, all are the examples of strong acids. Weak acids which are partially ionized and give only few H plus ions, known as weak acids. Next is dilute acids. Those solutions which have low amount of acid and high amount of water are known as dilute. But if acid amount is more, then it is known as the concentrated acid. What is neutralization reaction? When acids reacts with base to obtain salt and water is known as neutralization reaction. Next is about the strong base. Same, which are fully ionized and give OH negative ions are known as strong base. Weak base which are partially ionized. Chemical reactions. Acids reacts with metals to obtain salt and water or salt and hydrogen gas. Acids reacts with metal oxide to form salt and water. Acids reacts with metal carbonates to produce salt, water and carbon dioxide gas. Again, acids react with metal bicarbonates to produce salt, water and carbon dioxide gas. These are the reactions along with balancings. So note down. Next are the chemical reactions of base. Only three reactions, in which one is base reacts with metal to obtain salt and hydrogen gas. Base reacts with non-metal oxide to form salt and water, and base reacts with acid to produce salt and water. Next is some formula of acids, very important, and some bases are there, if having some uses also. Next is the strength, known as the pH value, that is power of hydrogen, that is the pH, power of hydrogen ions. So defined as the amount of hydrogen ions present in per liter of the solution. Okay, so the formula of pH is minus log of concentration of H plus ions. And remember that the product of concentration of H plus ions into concentration of OH minus ions is always 10 ki power minus 14. Next is the importance of pH in our daily life. Helps in digestion of food, can cause the change in decay of tooth. Lactic acid produced in our body during heavy exercise. Plants are sensitive and they defend themselves by stings. Next we are coming to the topics of salt. These are the chemicals formed by reaction of an acid with a salt, as with a base. So there are three types of salts. One is the acidic salt, basic salt, and neutral salts. Acidic salts, which are prepared by combination of strong acid and weak base. So basic salt, weak acid and strong base, and neutral, strong acid, strong base. Next we are going to the very important salt, that is sodium chloride. White salt, that is the common salt, generally used. Table salt we can use. Okay, it is obtained by evaporation of seawater and in laboratory prepared by combining HCl with NaOH, that is acid with base will form salt. Next we are coming to the properties. It is white solid, highly soluble in water, have high melting and boiling point, and it can absorb moisture from the atmosphere. It shows ionic reactions and reaction with sulfuric acid to form sodium hydrogen sulfate. Uses to bake food, used as preservative, and used in freezing mixture. Next is the sodium hydroxide, that is the compound obtained from NaCl. It is a strong base called caustic soda and prepared by chlor-alkali process. In this process, the electrolysis of brine solution is done. Chlorine is obtained at anode and hydrogen gas is produced at cathode. Okay, so this is the reaction. NaCl will give NaOH plus chlorine at anode and hydrogen at cathode. Next, what are the properties and uses? It is a white compound, soluble in water, high melting and boiling point, corrosive in nature, soapy in touch, and good conductor of electricity. Used to prepare soap, manufacturing of textile, paper, any two uses you can remember. Next is about the washing soda. It is the sodium carbonate decahydrate. It has cleansing property to prepare detergents. The preparation method includes 3 steps. In the first step, NaCl reacts with ammonia, water and CO2 to obtain sodium hydrogen carbonate plus ammonium chloride. This sodium hydrogen carbonate further heated to form sodium carbonate, and at last to sodium carbonate we add 10 molecules of water of crystallization to obtain the washing soda. Next is what are the properties. It is a crystalline solid, highly soluble in water, having cleansing properties. It loses 9 molecules of water on exposure to air, and on heating it loses all the 10 molecules, leaving behind anhydrous compound known as soda ash. It is used in manufacturing of detergent, used for softening of hard water, and manufacturing of glass and paper. Next is sodium hydrogen carbonate. It is the already discussed product preparation, that is NaCl, NH3, H2O plus CO2 will form NaHCO3. This is the first step of the washing soda. It is a white substance. It is less soluble in water. It is slightly alkaline, and on decomposed it gives soda ash. It is used to remove acidity of stomach. It can be taken with the small amount of lemon, etc. That is the ENO prepared from this. It can be used for preparation of baking powder by adding citric acid. Used in preparation of soda water. Next is the bleaching powder, that is formula is calcium oxychloride CaOCl2. It is chemically a chlorine releasing compound that causes bleaching. Prepared by simple adding slaked lime with chlorine, and yellowish white powder with smell of chlorine is there. It is soluble in water and its solubility increases with hot water. On exposure to air, it releases chlorine gas, which is used in the bleaching agent, bleaching powder. Next is the plaster of Paris, POP, having formula CaSO4 calcium sulfate half H2O 1/2 H2O. Prepared from gypsum, having formula CaSO4.2H2O. On heating at 100 degrees Celsius, it converts into POP. But if heating increases more than 100 degrees Celsius, then it will form dead burnt plaster. It is off-white powder, soapy in touch, and on heating it converts into solid mass. Less soluble in water and absorbs moisture to produce, that is the gypsum. Next is the hydrated salts. Those salts which are having fixed number of water molecules are known as hydrated salts. Example, copper sulfate is having 5 molecules of water, washing soda is having 10 molecules of water, FeSO4 is having 7 molecules of water, gypsum is having 2 molecules of water. So this is all about the revision of chapter. You have to completely revise it, and I will giving you Aschant questions. You will have to solve all the Aschant questions. Thanks.